Let matrix A be A, B, C, D if A times D, which is the main diagonal, minus B times C is not equal to 0, then matrix A is invertible. And the formula for the inverse is 1 over AD minus BC. But then the matrix afterwards is you switch places with A and D, and then you negate B and C. Switch places with A and D, negate B and C. This multiplication of AD minus BC, AD minus BC is called the determinant of A. So that's the requirement, is the determinant can't be 0 because it's the denominator here. Find A inverse if matrix A is the 2 by 2 matrix 3, 4, 5, 6. The determinant is the first thing you calculate. 3 times 6 minus 5 times 4, or 4 times 5, however you want to do it. I actually recommend using your calculator. 18 minus 20 is negative 2. That's not 0, so we can continue. 1 over the determinant. Change places on your main diagonal, so 3 and 6 swap places. 4 and 5 each get negated. Now, if the original number is negative, when you negate, you'd get a positive. So you swap and negate. And then if you were to multiply all 4 entries by negative 1/2, you would get negative 3, 2, 5 halves because of the 2 negatives, and negative 3 halves. If A is an invertible n by n matrix, then for each B belonging to Rn, the equation AX equals B has the unique solution X equals A inverse times B. Carrying A over to solve for X, you have to invert. So X is equal to A inverse times B. Let's solve this system of equations. We're going to pull all the coefficients for matrix A, 3, 5, 4, 6. Matrix B, that's going to be comprised of the values each equation is equal to. And then we're solving for X, so we still have our column vector x1, x2. This is our matrix equation, AX equals B. From above, we know the inverse of this one, because we did it up here, is this matrix. So if we take A inverse times B, and we multiply those together, our solution is 5, negative 3. X1 is 5, X2 is negative 3. An n by n matrix A is invertible if and only if you ever see where I've written IFF, that's shorthand notation for if and only if. A logic statement works both ways on an if and only if statement. Okay, so an n by n matrix A is invertible if and only if A is row equivalent to an identity matrix. Any sequence of elementary row operations that reduces A to an identity also transforms the identity into the inverse. Let's see how that looks. If you had to do it by hand, what you would do is, if you're given, in this case, we've got a 3 by 3 matrix, you stack it in the front. Then behind it, you would put a 3 by 3 identity matrix. Row-reduced echelon form will transform the original matrix to the identity matrix, assuming it does have a solution. Maybe a better way to say it is if it's going to have an inverse. What follows is the inverse of the original matrix. You can check by putting the original matrix in your calculator. The inverse, you might call it matrix B, but if you multiply these in both orders, you will get the I3 identity matrix, which would be this one. or this one. These last two slides, in Google Drive, I would recommend that you just print these last two, and that way you'll have them handy. In the last block of your homework, like the last 4 or 5 questions, they're kind of true-false type questions, and you can use these notes. I'm going to switch to the next slide, but again, when you go to Google Drive, Unit 2, when you pull that up, you'll see that these are the last 2 pages in that particular document. And here's the second page to it. These little parts here, let me see if I can't ink these in. Where these boxes are, those are supposed to be the R's. For some reason, the software that I have wouldn't translate them on here. But just to make a note, when you do print these last 2, or if you do print them, when you see those empty boxes, please replace with the bold real number notation, like that. All right, so I hope this helps. I'm going to save the ink on this video, so when you watch it, it'll be a reminder to print these off. When you do, fill in the empty boxes with the bold stamped R in for real numbers.